We are moving on to a new topic. 1-2, fluently divide whole numbers and decimals. This is a 6 NSB2 standard, as you can see here. You need to turn to page number 27. Hopefully you are already on that page. We're on page number 27 in our guided notebook. So get that open. We're going to be taking notes, and of course, as always, you upload your picture. The goal is for you to understand and learn, get the questions correct on your ed puzzle. That way I know what you understand and what you kind of still need to work on. So we have 4 objectives for this lesson. We want to divide whole numbers and decimals, divide multi-digit decimals, understand the divisor must be a whole number. I want you to highlight that because that's one of the most important things. Your divisor must be a whole number, and I'm going to show you exactly what I'm talking about. And if you make your divisor a whole number by multiplying by a power of 10, you have to make sure you move the dividend decimal point the same number of spaces in the same direction, which means you're multiplying by the same power of 10. So this objective 3 and 4 is really important for this lesson. So I want you to highlight that. And then we have 3 essential questions. How do you divide whole numbers and decimals? How can you divide decimals as easily as you divide whole numbers? And the last one, how do you know which power of 10 to multiply the divisor by? So that question, number 3, is so important that I'm going to go over it to make the divisor a whole number. So this is my divisor right here. So this divisor is 5/10. So in order to make 5/10 a whole number, I need to move the decimal point 1 time to the right, which is multiplying by 10. So if I were to write this as a fraction, it would look like this. So in order to make my divisor, which is my denominator, a whole number, I will have to move the decimal point to the right, which is multiplying by 10. And since I moved the decimal point to the right 1 time for the denominator, I need to move the decimal point to the right 1 time for the numerator as well, which is multiplying by 10 to maintain equivalency. So my new number is going to be 32 and 5/10 over 5. Notice my divisor is a 5 and not 5/10. Now this is how you would divide. So how do you know which power of 10 to multiply by? Since we need to move the decimal point 1 time to the right, we multiply by 10 to the first power, which is equivalent to 10. So our divisor needs to be a whole number. If I were to write this in a standard long division, the original would look 3 25/100 divided by 5/10. So our divisor needs to be a whole number. So this is the divisor. This is the divisor. And this is the divisor. So remember, there are 3 different ways to write the division, standard long division, using a division symbol as a fraction. So you need to recognize which one is the divisor for all formats, so you will get this correct. So you have to move the decimal point 1 time to the right here, move the decimal point 1 time to the right here. Your new decimal point is behind the 2. You move it right up above it in the quotient. So the goal is to maintain equivalency. Now let's look at the next one. So this one right here, our divisor is the 5. And since our 5 is already a whole number, we're just going to leave it alone. Because our divisor is already a whole number. So the goal is to make your divisor a whole number. If it's a whole number, you want to leave it alone. Now let's look at this next one. We have 3 25/100 divided by 5/100. So since our divisor is not a whole number, we want to make our divisor a whole number. So we want to move the decimal point 2 times to the right. So that's multiplying by 100. 2 numbers, 2 zeros, 100. We have to multiply by 100 to make 5/100 a whole number. And since we multiply the divisor by 100, we have to multiply the dividend by 100 as well. And our decimal point will be behind the 5. Our new decimal point is behind the 5. So whatever you multiply the divisor by, you have to multiply the dividend by the same exact power of 10. So this one right here is equivalent to 10 to the second power, because 10 to the second power is 10 as a base, as a repeated factor twice, which is 100. Remember, the exponent tells you how many times your base is a repeated factor. The exponent is 2. It tells you how many times your base 10 is a repeated factor. So decimals work with the power of 10, so you can just move the decimal point to the right or to the left. And then we have some vocabulary words that you need to know. Quotient is the answer to a division problem. We talked about this. And remainder is the division. The remainder is the number that is left over after the division is complete. So here we have a question. A family is heading out on a car trip of 672 miles to what is known as a sixth most popular national park, the Blue Ridge Parkway. If they travel at an average of 56 miles per hour, how long will it take to get there? So if you think about it, for this question, we're taking out groups of 56. Every time we drive 56 miles, we complete 1 hour of the drive. So we have to start with the total number of miles for the trip, which is 672 miles. And then we have to divide it evenly into groups of 56. And however many groups we have of 56 miles, that's going to represent 1 hour. So our answer is going to be in hours. So you can use estimation to figure out your answer. So 672 rounds to about 660. And that was chosen because 56 rounds to 60. And you can easily put 60 into 660. So you just making compatible numbers. It doesn't necessarily have to round. 672 will round to 680, but since 660 is a compatible number to work with 60, you would change it to something that's easy to work with, not necessarily just rounding both numbers. So I want you to write down your given information. So some given information here is that we have a 672-mile car trip. We complete 56 miles per hour. And remember, per means for each or for every. So 56 miles that we drive, we're going to complete an hour. And then we want to figure out how many groups of what are in what. How many groups of 56 miles are in 672 miles? That's the question that we want to answer. The number of groups is the total number of hours. So let's squeeze that here. I'm going to put it right here. The total number of groups you can make is going to be hours. So obviously we want to figure out 672 divided by 56, where 56 is our divisor, what we're making groups of, and 672 is our dividend, what's being divided evenly into groups. All right, so once you have that written down, go ahead and turn to page number 28, partial quotient method. It's kind of similar to the standard logarithm. This one is more reasonable, and because it's forcing you to understand place values. So you would just figure out how many times 56 going to 672. The answer is 10. Then you subtract, multiply, subtract. You have 112 left over. Figure out how many times 56 going to 112. The answer is twice, and then you will add those two numbers up. I don't want to use that method. That's just another way to do it. The method that we're going to use, because it works with decimals, is the regular standard logarithm, where we figure out how many times the divisor go into a number, and then we just kind of ignore place values, but we still keep place values in mind by placing our number over the correct numbers. So we're going to put this into examples. So some steps that you can think about when you're dividing. We're not going to use the remainder. We're going to make fractions, or we're going to make decimals in 6th grade. But some steps that you can keep in mind is you want to divide, multiply, subtract, bring down. So that's some different things that you could use. Whatever method you've been using before, I want you to continue to use that method. We're on the bottom of page 28, and we're going to complete this here. So we have 254 divided by 29. Actually, I'm going to change this to 400. I want you to change this to 454 divided by 29. All right, so let's do, how would you write this in the standalone division? 454 divided by 29. So I'm going to use compatible numbers to figure out my answer. So write this. I know that 29 is close to 30. And then 454, I'm just going to say 450. So I know 30 can go into 45 one time, so I put a 1 above the 5. So the first number that I'm going to try is 29 probably can go into 45 one time. So I'm going to check, well, I'm going to put 29 here. I'm going to put a 1. 29 times 1 is 29, and then I subtract. I have to regroup because I can't take 9 from 5 because it's smaller. I'll end up with a negative number. So this is going to become a 3. So you can go ahead and subtract. I'm going to regroup. This is going to become 15 because I'm sending 10 back. Now I can take 9 from 15 to get a 6. And then I can take 2 from 3 to get 1. Now I know that the 1 is correct because my remainder is not greater than my or equal to my divisor, what I wanted a whole group of. So I'm going to bring my next number down, and then I'm going to think, how many times do you think 30 will go into 164? We can ask ourselves, how many times does 3, so basically this rounds to 30, so we can kind of ignore this. Well, let's say this was 30. We can kind of ignore this right here and ask ourselves, how many times does 3, because 2 that rounds to 3, how many times does 3 go into 16? And the answer is 5. So the first number I'm going to try, how many times does 3, so imagine if that was a 3, go into 16? So I kind of just ignore these two numbers here just to get a compatible number. How many times does 3 go into 15? So the first number that I'm going to try is 29 times 5, because 16 divided by 3 is 5 wholes. So I'm going to try 29 times 5 first to see what number I get. 9 times 5 is 45. And then we have 10. 5 times 2 is 10 plus 4 is 14. So 145, let's see. So let's try a 5 here. 5 times 29 is 145. Then I'm going to regroup. 15. So since my remainder 15 is lower than my divisor, what I wanted a whole group of, I know my answer is correct. So I'm just going to make a fraction. So the part that I have left over is 15, and I wanted a whole group of 29. So it's 15 and 15 29s. So you can use compatible numbers, kind of ignore the first number. You do some different things to figure out what number you should use, what number should go above that number in the quotient. So the next one is 784 divided by 25. So when you're dealing with 25, you can think of quarters. So you can think of how many quarters will go into $7.84. So we know there are 4 quarters in a dollar. So we can think of it like that. So we know that 25 cannot go into 7. So we're going to move to the next number, and we're going to figure out how many times does 25 go into 78. Now we can do that. So we're going to figure out how many times 25 goes into 78 first. So 25 plus 25 is 50, plus another 25 is 75. So I know it's going to be 3. 3 quarters is 75 cents. So 3 times 25 is 75. And then I'm going to subtract. 8 minus 5 is 3. And then I'm going to bring down my next number. So I'm going to bring down this 4 right here. And then I'm going to ask myself, how many times does 25 go into 34? And the answer is 1. So since I brought down the 4, I know that I need to put the 1 above the number that I just brought down, which is the 4. And 25 times 1 is 25. And then we will subtract. So we have to regroup. And we have 9 left over. And we can make a fraction by putting 9 over 25. So you have to figure out how many times does the whole number go into the number, put the number, multiply, subtract. So it's just practice. And this is nothing new from last year. The same way you divided last year is the same way you divide this year. You just can use compatible numbers. All right, so here is the next one. We want to use the information in the diagram of the reflection pool to find the reflection pool's length. So we have a picture here of a pool, and we have an area of 338,843 feet squared. And then we have a width of 167 feet. So we should know that area is equivalent to length times width. So we can rewrite this as division by taking the area and dividing it by the length to get the width, or taking the area to divide it by the width to get the length. And you do need to know this, so you can put a star here. So we have to start with the area, which is 338,843 divided by 167. And then once we divide, we'll have our answer. So we have to figure out how many times does 167 go into 338. And the reason why we're going to use 338 because we know that 167 can't go into 3. So we're not going to use that. So we're not going to put a number above that 3. So we're going to move to the next number. Ask yourself, how many times does 167 go into 33? 0 times. So we're not going to put a number above this 3 right here, because place values is important. So we move to the next one. We ask ourselves, how many times does 167 go into 338? And that answer, we can take a group of 167 out of 338. How many groups? 2 groups. Because 167 times 2 is 334. So I'm going to go ahead and subtract. And the reason why I put the 2 above the 8, this is really important when we're dealing with decimals, because 167 went into 338. So you put that number above the last number. So I'm going to put 334 here, and I'm going to subtract, and I have 4 left over. So I'm going to bring down my next number, which is an 8. Every time you bring a number down, you have to put a number in the quotient. So 167 goes into this 48 0 times. So you have to put a 0 above that 8. And then 0 times 167 is 0. And then we have 48. I'm going to bring my next number down, which is this 4. My next number is this 4 right here. So I have to put a number right above the 4 in the quotient. Before you do anything else, you always put a number. If it goes into that number 0 times, you put a 0. But you have to put a number there. And we have to see how many times does 167 go into 484. So I'm going to try 167 times 3 just in case. So we have 7 times 3 is 21. 3 times 6 is 18 plus 2 is 20. And then we have 3 times 1, which is 3 plus 2, which is 5. That is too high. So I know 167 times 3 is too high. So I'm going to go with the 2. So I'm going to put, so 167 goes into 484 2 times. So since I brought down the 4, I'm going to put that 2 right above that number that I brought down. And then 2 times 167 is 334. And I'm going to subtract 4 minus 4 is 0. 8 minus 3 is 5. And then 4 minus 3 is 1. Now I'm going to go to bring down my next number. So you keep bringing down your numbers until you don't have anything left to bring down. So my next number is a 3. So I'm going to bring down the 3. and however many times 167 going to 1,503, I'm going to put that number above the 3, since the 3 is the number that I brought down. So I'm going to use compatible numbers here. So I'm going to say this is about 200, and then I'm going to say this is about 1,500. So I'm going to ask myself, I'm going to just kind of ignore this, cross off this number, the last number, cross off this number, the last number, and ask myself, how many times does 2 go into 15? And that answer is 7 times. So the first thing I'm going to try is 167 times 5. And you can write this at the top. So that's going to be 35. And then I have 30 plus 3 is 33. And then I have 8. That number is way too small. So sometimes this method works and sometimes it does not. So I'm going to go up a little bit more, a number up. So I'm going to do 167 times 6. Let's try that one. So 6 times 7 is 42. 6 times 6 is 36. Plus 4 is 40. And then 6 times 1 is 6 plus 4 is 100. That number is still too low. So I'm going to try 167 times 7. I'm actually not going to try 7 because 167, if I add another 200, that's only going to take me to 1,200. And I need to go all the way to 1,500. So I need to go up more than 7. And if I add another 200 to that 1,200, that'll be 1,400, which is still too low. So that I'm going to go above 8. So I'm going to actually try a 9. That would make more sense to try a 9. So I'm going to try 9. 9 times 7 is 63. And then 9 times 6 is 54. Plus 6 is 54, 55, 56, 57, 58, 59, 60. So we put a 6 and put a 0. And then we have 9 times 1 is 9. Plus 6 is 15. And there's our number right there, the exact number that we need. So I'm going to go ahead and take these x's off. 167 goes into 1,500 9 times. 9 times 167 is 15. 1,503. And then my number terminates in the ones place. So this is the answer, 2,029 feet. All right. When you multiply a decimal divisor by a power of 10 to change it to a whole number, why do you need to multiply the dividend by the same power of 10? So an example of that is if you have, let's say 0 and 2/10 as a divisor, and we have 18 and 43 hundredths. You have to make your divisor a whole number by multiplying it by the power of 10. So we have to move it one time to the right, so that's multiplying by 10. If you do not multiply the dividend by the same power of 10, your decimal point is going to be in the wrong spot, because your new decimal point will be in between the 4 and the 3 and not between the 8 and the 4. So if you do not multiply the dividend by the same power of 10 that you multiply the divisor by, you will not get an equivalent answer. So let's go ahead and write that down. So you can think of division as a fraction. So if I were to write this as a fraction, it will look like this. And division is a fraction. The dividend is the numerator, and the divisor is the denominator. So if you multiply the denominator by a power of 10, which in this case we have to multiply the denominator by 10, since we have to move the decimal point one time to the right. Moving to the right is the same as multiplying by 10. Since we multiplied the denominator by 10, we have to multiply the numerator, which is the dividend, by the same power of 10. So our new decimal point is going to be in a new spot. So we multiply by the same 10, which is 10 to the first power. So that's going to make our divisor a whole number, which is 2 now. And our numerator is going to be 18,184 and 3/10 instead of 18 and 43/100. And the reason why we need to do that is multiply by the same power of 10. You have to multiply the numerator by the same power of 10 to maintain equivalency. All right, so to maintain equivalency is the reason. So if you want an equivalent answer to the original expression, you have to make sure you perform the same operation to the numerator and the denominator the same way you simplify fractions and multiply fractions to make equivalent fractions, or divide fractions to make equivalent fractions. It's the same exact concept. These are some general rules that you can use when you are dividing with decimals. The main thing that you have to remember is this bottom part right here, and I want you to highlight it. Your divisor must be a whole number. How? By moving the decimal point to the right, however many times necessary to make your divisor a whole number. The focus is on the divisor, not the dividend. Then, once you make your divisor a whole number, you have to make the dividend, multiply the dividend by the same exact power of 10. So you want to write it in standalone division. This is step number 1. Multiply the divisor by a power of 10. So you want to change this divisor into a whole number, so the decimal point was moved 1 time to the right. And then you want to multiply the dividend by the same power of 10. So I want you to put times 10 right here. So since we multiplied the divisor by 10, we have to multiply the dividend by 10 as well. So our new decimal point is between the 2 and the 5 and not between the 2 and the 2. And then you want to place your decimal point from the dividend to the quotient. And then you would divide as normal. See how many times 5 goes into the numbers. Your decimal point is already placed, so you divide as normal. If your decimal does not terminate, you would just add a 0 in the dividend, bring it down, and keep dividing. So those are the steps, the general rules. The main thing, your divisor must be a whole number. So we're going to look at an example. So last week, a 6th grade class received $10.32 for aluminum cans they recycled. The scrapyard paid them 48 cents for each pound. How much pound of aluminum cans did the class recycle? Well, what do we know? So what information do we know about this problem? We know that the students received $10.32. So that's all that they received. We also know that they received 48 cents per pound, or for each pound. So we have to know, what operation is this? We also need to know what we need to find. So erase this need and put find right here. So we want to find how many pounds of aluminum cans did the class recycle. So that's the question that we want to answer. So what is our plan? Our plan is to divide, because we're trying to figure out how many groups, how many pounds. So if we replace that pounds with the actual numbers, it will be 48 cents per pound. So the pounds can be replaced with 48 cents. How many 48 cents of aluminum cans did they recycle? So how many 48 cents are in $10.32? That'll help us to get the answer. So everything that we have is our dividend, and that goes inside of the house. So in this case, it's going to be $10.32. And then our divisor, what we want to make groups of, and every time we make a group, that's going to be one aluminum can. So we're going to put 48 cents here. Now, we don't want our divisor to be a fraction. We don't want our divisor to be a part out of a whole, because this is 48 hundredths, which is really 48 hundredths. We do not want our divisor. We don't want to make groups of a fraction. We know how to divide a whole number, so we're going to change our divisor into a whole number. So if I have to move this decimal point how many times to the right to make 48 hundredths a whole number? 1, 2 times. 1, 2 times, so that's like multiplying by 100. So since we had to move the decimal point 2 times to the right for the divisor, which is multiplying by 100, we have to do the same thing for the dividend. So we have to move this decimal point 1, 2 times, 1, 2 times, which is multiplying by 100 as well. So if we wanted to write out our new expression, we will write it as 1032, because our new decimal point is behind the 2, divided by 48. Now that our divisor is a whole number, we can divide like normal. And write underneath what you just wrote here, underneath the plan, I'm going to rewrite it, and then I'm going to work it out. So we have 1032 divided by 48. So our new decimal point is behind the 2 if we needed it. So I'm going to use compatible numbers. So I can say that 48 rounds to about 50, and 1032 rounds to about 1050. I'm just going to put that. So I'm going to first think, how much is 50 going to 1? That answer is 0 times, so I'm not going to have a number above the 1. Then I'm going to ask myself, how many times is 50 going to 10? That is 0 times, so I'm not going to put a number above the 0. Then I need to ask myself, how many times does 50 go into 105? That's about 2 times. So the first number I'm going to try is 48 times 2. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. So this is the number that I need here, because if I add another 48, which is 2 times 3, that number is going to be too high. So I'm going to put 2 here. 2 times 48 is 96. And then I'm going to subtract. I have to regroup. 6 from 13 is 7. And 9 from 9 is 0, so I'm not going to bring anything down here. So I'm going to now bring down my next number, which is this 2 right here. And I'm going to ask myself, well, how many times does 50 go into 72? How many times does 50 go into 72? And that answer goes into 72 one time, because if I do 50 plus 50, that's 100, and this is not 100. So I'm going to do 1 times 48, which is 48. And I'm going to subtract. I have to regroup. This has to go down 1, and I'm sending 10 back to the place value that's lower. 10 plus 2 is 12. 8 from 12 is 4. And then 4 from 6 is 2. So now I'm going to come here, and I'm going to add a 0 and bring it down. Add a 0 in the dividend and bring it down. You only can add zeros after decimal point. So it's really important for you to put your decimal point, and you can add as many zeros as you want after the decimal point. So now we want to figure out how many times does 48 go into 240. So we can think, how many times does 5 go into 24? We can think like that, because if we take off this 8, the last number here, which is 8, and if we take off this 0, we can see how many times does 4 go into 24, or how many, since 48 is closer to 5, you can see how many times does 5 go into 24. I'll try 5 first because it ends with a 0. But I'm going to do 48 times 4 first. So 4 times 8 is 32. 4 times 4 is 16, plus 3 is 19. So let's just see if it's a 4. So I know 4 is incorrect. I want to show you something. 4 times 48 is 192. So if I pick this number right here, I will have to regroup. So this is going to become a 3, send 10 back, we have 8, and this is a 1, I'm sending 13, 4. Look at that. So since my remainder is the same, my remainder 48 is the same as my divisor, that means I can make another group of 48 to take from this 400 and 240. So that means that this 4 that I put up here is incorrect because my remainder is equal to my divisor. Whenever your number is equal to your divisor or greater than your divisor, that means you can take more groups of your divisor, and this number right here should go up. So keep that in mind when you're dividing. So I'm going to backspace. Now I'm going to put a different number there. So the number that you should have picked is 5 because 48 times 5, as we saw that we can take another group of 48 out, it has to be 240. So 5 times 8 is 40, and then 5 times 4 is 20 plus 4 is 24. So that means we can take 5 whole groups of 48 from this 240. So I'm going to go ahead and subtract those 5 groups, which is equivalent to 240. And now my decimal terminates. This is a terminating decimal because it terminates in the 10th place. So this is the answer right here. The class recycled 21 5/10 pounds of aluminum cans.